Alright, today we're doing section 3.5 day 2. So just like with the rest of this chapter, we do some problems, solving equations, and then we move on to writing our own problems and solving those equations. So today we're going to be writing our own problems. But first let's revisit what we did yesterday. Keon, how did you solve number 1? Okay, so we don't just subtract 2, right? We subtract 2x. Good. Seven x equals 21. Very good. And then what did you do next? So how did you come up with that? Okay, so we need to divide on both sides. I think you're close, but 21 divided by 7 is 3. Good. Is that what you said? I thought. Oh, okay. Sorry, I must have misheard you. Very good. So we have to get all of our variables on one side of the equation, and then we can use our inverse operations to solve it. All right, Natalie, what did you do on number 2? Good. Okay. Wonderful. All right, so again, we get all of our variables together and then we start solving. Also, we talked about yesterday, it's not a requirement, but it's recommended if we move the smaller variable. So we treat that like a negative 8t. Negative 8 is smaller than 4, so that's why we chose to move that one. It's not the only way to do that problem, it's just the one we like the best. All right, number 3. Danielle, what did you do? Okay, when we distribute, what do we get?
3k minus 24 equals k.
Wonderful. We distribute, so we multiply to both k and the minus 8. What happens next?
We add 24 to both sides.
Okay, we can add 24 to both sides. Start moving things around to make this simpler. What does that leave us with?
3k equals k plus 4.
3k equals k plus... K plus what? I'm sorry, I didn't hear you.
K plus 4.
28? We add...
K plus 28.
Okay, we add 24 and 4, we get 28. All right, what would happen next?
Subtract k from both sides.
Very good. We got to get all those variables together. I'm going to move on over here to keep going. I've got enough room to show my work. All right, when we subtract k from 3k, what do we get?
2k.
2k equals 28. Wonderful. And finally, our last step,
Divide both sides by 2.
divide by 2. What do we get for k?
K equals 14.
Wonderful. Again, not the only order that we could have done that problem in, but that's a wonderful way to go about it. Our only note for today is that we can also solve word problems where there is a variable on both sides of the equation. We can solve word problems when there is a variable on both sides of the equation. So number 1 says, find a number that is 20 greater than its opposite. Okay, so first thing, Define a variable. Lexi, what's our variable going to be? N. That's a good one. What does it represent, Lexi? A number. That's what we don't know. We don't know what that number is. So N is going to represent a number. So we are told to find a number. So above the word number, I can just put my N. That is, Nevaeh, what do we think of when we see the word is?
Equals.
Equals. Very good. That equals 20 greater than. Tariana, greater than makes us think of what operation? Addition. So we're adding 20. 20 greater than its opposite. Now this is the part that gets a little bit tricky because we haven't spent a lot of time talking about this. Ryan, do you think you know how we would represent that? Close. I like the negative part for opposite, but we want the opposite of the number. Natalie?
Negative N.
Negative N. Very good. So the opposite of our number is represented by negative N. If we wanted the opposite of 20, then yes, negative 20. So it's the same idea. Okay, so we've got these notes up here. But what do you think we need to rearrange to actually write our equation? Keon? So what would you write?
N plus.
Okay, I think you're on the right track. Ellie, do you have the whole equation?
I was thinking N equals negative N plus 20.
Very good. So we just kind of rearrange our negative N and the plus 20 to make a full equation. So don't let these problems scare you. Just take them one step at a time, and we're able to write an equation. After that, hopefully this part is the easy part. This is what we did yesterday. We have to solve them. So I need to get all my variables on one side of the equation. Jaquan, what do you think I need to do to get my variables all together? Add what? Add the N to both sides. Good. We want this one to zero out. If it's negative, it's going to zero out when we add it. But if we do it to one side, we do it to the other side. All right, May, what is N plus N going to give me? 2N equals that. 20 is all that's left over there when those N's zero each other out. Jakeem, what are we going to do to solve this? Divide by 2. Very good. And what do we get, Jakeem? N equals 10. Wonderful. What questions do we have about this? We're ready to try some more? Find a number whose product with 7 is the same as its sum with 18. So once again, we start by defining a variable. Shannon, what variable are we going to use this time?
Oh, yeah, we'll use N again, bro.
Sure, we can. What is N going to represent? Okay, so Shannon was saying that N is going to represent a number again in this case. If you want to use a different variable, you are more than welcome to. But it's nice to use N for a number. Find a number, so number, we should think N, whose product with 7. So what does that mean we're doing to this N, Jalen? By 7. Okay. So we could write that as N times 7, or we can go ahead and write it as 7 times N. Or 7N. So a number whose product with 7 is the same as, Logan, the word is makes us think of what? Well, thank you, Tariana, for helping out. So Logan, the word is, every time we see it, that's going to make us think of the equal sign. That's the symbol we should use there. is equals the same as its sum with 18. So here it's tricky. The word its, here it's a small word, but it's very important. Its refers back to our number. So we have to think of that number again when we see its. So n again. Houston, the word sum should make us think of what operator? Not multiple. Addition, good. So the sum with 18. Now this problem worked out pretty nice because after we put all of our notes in place, really we just have to string it all together and it gives us our equation. 7n equals n plus 18. I know we don't like having extra steps, but if you take the time to write those notes out first, it'll help you make your equation later. All right, then we have to solve it. Deja, how would you solve this one? Subtract n on both sides. What does that give us? 6n equals 18. And the last step? Very good. We get n equals 3. Wonderful. All right, what questions do we have about number 3? You ready to take it up a notch? Maybe. Again, we're going to do the odds together, and then we'll have time to go back and do the evens. Number 5. 5 times a number decreased by 10 is the same as twice a number increased by 11. Find the number. All right, once again, we start this all over. We have to define a variable and what it stands for. Jerry L., what variable do you want to use? Okay, and what do you want it to represent? What is it that we're looking for? At the end, it tells us to find the number. That's what we're looking for. That's what our variable should represent. So a number or the number. All right, so we go through and we start making notes. 5 times a number. What was that, Jerry L? 5n, very good. 5 times a number, that's multiplication. So 5n decreased by 10. Kelby? Decreased by 10 should make us think of what operation?
Subtraction.
Subtraction. So we are subtracting 10. Is, everybody in the whole class, is should make us think of? Equals. Very good. Is equals. Is the same as, so just is, twice a number. Connie, what would twice a number be? Times 2. So what times 2? N times 2. Very good. We can write it as n times 2, or you could just write it as 2n. Increased by 11. Jakeem? So we're not increasing the 2 by 11, but increased by 11 means we're doing what operation? Addition. Good. So we're adding 11. Break it up. Take it one piece at a time. And now look, we've already made our whole problem. Okay? If you just chunk it up, it's not quite so bad. So don't see all the words and get scared. Now this one we don't even have to rearrange. In order it makes sense. 5n minus 10 equals 2n plus 11. But now we get to solve this problem. Ellie, what are we going to do?
sides first.
Okay.
Then I got 5n equals 2n plus 21. And then I subtracted 2n on both sides. I got 3n equals 21. And I divided 3 on both sides. And I got n equals 7.
Classmates, what do we think of that?
Correct.
Wonderful. Yes, we should all agree. I like those steps. If you subtracted the 2n first and then added the 10 to both sides after, that's okay. It's just a different order of doing it, but it gets you the same answer. As long as you showed all your work, we're all good to go. What questions do we have about number 5? Okay. All right, then one more that we're going to do together before I let you have some time to work on your own and see what you can do. Number 7, the greater of 2 consecutive integers is 22 more than twice the smaller. Find the integers. Now I will admit, reading this, it sounds awfully intimidating, but we're just going to take it one step at a time. First thing we need is to define a variable. Jamaro, what's our variable? You want to use n. Keeping it consistent, I like it. And n's going to represent what? A number, or in this case we're talking about integers. Okay, so integer. Now on this one it might be best if we specify the fact that n is going to be our smaller integer. The smaller integer is going to be n. Now we also need to revisit consecutive integers. This is something we talked about earlier in the week when an integer comes one right after another. So if n is our first integer, the integer after that is represented. Not equals. Plus 1, right? If we start at a number and we want to get to the number right after that, we add 1 to it. So if n is our smaller one, the next one is going to be n plus 1. So that makes our greater integer n plus 1. So the greater of 2 consecutive integers, that's going to be n plus 1. That's what's hard about this problem, is knowing that we have to define that n is the smaller one and n plus 1 is going to be the bigger. Okay, so n plus 1 is, everybody? What does is mean? Equals. I think I've asked you guys that question about 50 times this week. Well, that's okay, because we need to remember that. Is 22 more addition? Thank you, Danielle. Sorry, Deja. You guys sit right next to each other. I hear voices. It happens. All right. Adding what? 22. So we're adding 22. Twice the smaller. Jalen, what do you think twice means we should do? Multiply by? Not by 22. Twice, Ellie? N and what number? 2. Okay, twice means multiply by 2. That's a special word because we just have to kind of inherently know that. It's not like there's the word times or the word of. So twice, we need to think of times 2. And we already said the smaller integer is n. So 2n. Find the integers. All right, n plus 1 equals, but what do you think we need to do with this side over here? Yep, we need to rearrange them to 2n plus 22. Jamal, Dixon, how did you solve this, or how would you solve this?
Subtract the 1 from both sides.
Okay. What would that leave us with?
A equals 2n plus 21.
All right. What comes up next?
Subtract 21 from both sides.
I think I want to leave the 21 alone. We need all the variables together.
2n.
So good. Subtract the 2n from both sides.
That gives you 1n. Negative 1n.
Very good. Negative 1n equals 21. But we don't want negative n. What do we want? The variable all alone. So we don't want a negative sign in front of it. We want it to be a positive. Nevaeh, what do you think we're going to do? Divide by? Not by a 2. Good, by that negative 1. So if we divide both sides by negative, that's going to flip our signs. So instead of a negative n, we've got a positive n. Kian?
Why did you subtract 2?
Down here?
Yes.
We subtracted 2n to zero them out to get all the variables together on one side. If in the beginning you wanted to move the n instead, you can. This is just a different way of doing it. Okay? But either way, in the end, we should all be getting 21 divided by negative 1, which equals negative 21. If you had moved the n in the beginning instead, then your answer would have been positive. You would have had a positive n. You wouldn't have had to divide off the negative. But it's okay as long as you show your work and I can see how you're getting your answer. Okay. All right, on problem 2. Find a number that is 48 less than its opposite. Do we have a group that wants to volunteer the equation they set up? Jicky. N equals, ooh, my pen is coming on, there we go. N equals negative n minus 48?
Yeah.
Wonderful. All right, so we're not going to solve them today because we got a short schedule, we're on time crunch. But if we get them set up, we should be able to solve them on our own.
Yeah.
Questions about setting up number 2? Do we have a group that, gentlemen, come on. I know we're almost out of here. Jaquan, you want to help us out with number 4?
I got n equals negative 4n plus 60.
Very good. N equals negative 4n plus 60. So the tricky part on this one was 4 times the opposite. So negative n times 4 gives us that negative 4n. Any volunteers to let me know how we set up number 6? Jamarl? Well, you raised your hand. You're going to volunteer your group member? Ellie, why don't you do this one?
I got 8n plus 30 equals 6n minus 20.
Very good. Again, on this one, our order matters with subtraction. 20 less means we subtract 20. Okay. Jerry L, you're going to help us out with number 8? Oh. Yes, with that pass, you may leave. Connie, what did your group get for this last one? Oh, we didn't quite make it there. Did any groups get there that I haven't heard from yet? Danielle, everybody's just voting you up. You want to help us out with this one, Danielle?
I guess.
Oh, thanks. What'd you get?
I got n plus 2 equals 2n minus 20.
Very good. So when we do consecutive even integers, we add 2. Okay. Equals 2n minus 20. Again, 20 less. We have to think subtraction. Now let's not get too excited just yet. I know we're almost out of here. But on your exit pass, I want you to try to write the equation. You don't have to solve it all the way through.
I get what you're saying.
I will grab one for you. You should have picked one up on your way in.
Write any equations?
Nope. The one for this problem.
We gotta solve it.
No, just write the equation out. And you're going to make sure your name gets put on it. You'll hand them to me on the way out.
I didn't realize I left my umbrella until I got to the last hour.
Oh no. Oh, okay. Yeah, you'll hand them to me on your way out so that we